Triangle inequalities. Triangle inequality theorem 1 states that if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So this theorem is basically stating that the longest side of the triangle is opposite from the biggest angle. So since BC has a length of 5, the angle opposite from it, which is angle A, this is going to be larger than the angle that's opposite from side AB, which is angle C. So angle A is going to be larger than angle C. Now we're going to use that theorem here because it asks us to list the angles in order from smallest to largest. So the smallest, let's list that one first. So in order to find the smallest angle, we have to find the shortest side. 4, 7, 8. Since 4 is the shortest, we know that's going to be opposite from the smallest angle, angle C. Then the medium-sized one, 7, is opposite from angle B. So that is the medium-sized angle. And then lastly, 8 is the longest side. And this side is opposite from the largest angle, angle A. Triangle inequality theorem 2. If one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So this is very similar to the first triangle inequality theorem, it's just kind of backwards. So this time we're given the angle measures. Angle D is 60 degrees and angle E is 40 degrees. Since angle D is larger, it's going to be opposite from the longer side. So FE is going to be longer than the side that's opposite from angle E, which is DF. So here it asks us to list the sides in order from shortest to longest. Now we need to know the measures of all three angles in order to list the sides properly. So first we need to find our missing angle. So 48 plus 61 plus x, our unknown angle, they all have to add up to 180. 48 plus 61 is 109 plus x equals 180. And then if we subtract 109 from both sides, we have x is equal to 71. So angle F is 71 degrees. So using these three angle measures, we can list the sides in order from shortest to longest. So again, we want to start off with the shortest, so we have to find the smallest angle. 48 is our smallest angle, and that's going to be opposite from our shortest side, which is DF. Then our medium-sized angle, which is 61, is going to be opposite from the medium side length, EF. And then our largest angle, 71, is going to be opposite from our longest side, ED. So the idea is that using triangle inequality theorems 1 and 2, if you're given the angles, you can list the sides from shortest to longest. And if you're given the side lengths, you can list the angles from smallest to largest. Next, we want to talk about the exterior inequality theorem. So the exterior angle inequality theorem states that the measure of an exterior angle of a triangle is greater than the measure of either of the two non-adjacent interior angles. Now, if you remember the exterior angle theorem that we talked about previously, it states that the measure of angle 1 is equal to the measure of angle A plus the measure of angle B. So if this angle has to add up to the sum of A and B, it only makes sense that this angle would be smaller than A and this angle would be smaller than B. Triangle inequality theorem 3. This one states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if you take any two sides of a triangle and add them together, they have to be longer than the third side. Otherwise, they will not make a triangle. So here we're given 3 segment lengths, and we have to determine whether these segments can make a triangle. So this first one, remember, we have to add up the 2 side lengths and see if they add up to more than the third one. So if you test it out, each combination, 4 plus 7 is equal to 11, which is bigger than 6. And then you test 7 plus 6 is equal to 13, which is bigger than 4. And then lastly, 4 plus 6 is equal to 10, which is bigger than 7. So this one checks out, and we do make a triangle. A way to do this a little faster is if you just take the 2 shortest sides and add them up, they have to be greater than the longest side. So our 2 shortest here are 5 and 3. So 5 plus 3 equals 8. And 8 is not bigger than 11. So these sides cannot make a triangle. And let's do this last example. Again, you can take the 2 shortest and add them together. 8 plus 4 equals 12. Now this one's tricky because 12 equals 12. But remember, our inequality theorem says that the 2 sides have to add up to more than the third side. So since 12 is not bigger than 12, these side lengths also cannot make a triangle. Another way to use this theorem is that when we're given 2 sides of a triangle, describing the possible lengths of the third side. So if I give you one side is 2 inches and one side is 5 inches, there are infinitely many possible lengths for that third side of the triangle. So we want to know what that range is going to be. So we're going to do the 2 most basic things you learned how to do with 2 numbers. Add them and subtract them. 2 plus 5 is 7, and then 5 minus 2 is 3. Always take the bigger number and subtract the smaller one, because we don't want to deal with negative side lengths. So that third side of the triangle has to be bigger than 3, but smaller than 7. So you could pick any of those values between 3 and 7 for that third side. You could pick 3.1 inches, you could pick 4 inches, 6.5 inches, any number in between 3 and 7. But remember, you cannot include 3 or 7. It has to be bigger than 3, and it has to be smaller than 7. The Hinge theorem compares 2 triangles, and it states that if 2 sides of one triangle are congruent to 2 sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second. So I know that's really wordy, so let me try to explain it in simpler terms. We have this side RS is congruent to side VW, and we also have ST is congruent to WX. Now we want to focus on the angle that's in between those sides I highlighted. This angle is 100 degrees, and this angle is 80. Since 100 is bigger than 80, the side that's opposite from the 100, RT, this side is going to be longer than that side that's opposite from the 80-degree angle. And here's the converse of the Hinge theorem. If 2 sides of one triangle are congruent to 2 sides of another triangle, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. So here again, we have side AB is congruent to side DE, and side AC is congruent to side DF. So we want to focus on the third side. BC is 8 long, and EF is 7 long. Since 8 is longer than 7, the angle that's opposite from the 8, angle A, this is going to be larger than the angle opposite from 7, which is angle D. Here we need to complete the statement with less than, greater than, or equal to, and we're going to be using the Hinge theorem and the converse. So in this first example, we're given that side CA is congruent to DF, and side CB is congruent to FE. And we want to focus on the angle that's given between them, angle 105, and angle 110. So since 110 is bigger than 105, that means that the side opposite from 110, which is DE, this is going to be longer than side AB. So the length of DE is going to be greater than the length of AB. Let's go ahead and use the converse of the Hinge theorem for example 2. First we have that this side is congruent to this side because of our tick markings, and then the reflexive property gives us that this side is congruent to itself. So now we want to focus on the measurements of the third side. This side is 6 and this side is also 6. That means that the angles that are opposite from them, angles 1 and 2, those are actually going to be congruent because the side lengths opposite from them are also congruent. So the measure of angle 1 equals the measure of angle 2. That's it for this set of notes on triangle inequalities. I'll see you in class for more practice.